Amazon API Gateway is an AWS service for managing APIs at any scale. Broadly, it's categorized into two categories: REST APIs and also HTTP APIs. While both of these products helps us to build RESTful APIs, the REST API product in Gateway provides more advanced features and configurations. In a previous video, I walked through the building blocks of the REST API offering. If you're completely new to this, I highly recommend checking that out first to understand the basic features and terminologies. REST API supports different backend integrations to power the API that we are building, and AWS Lambda is one of that. In this video, we will learn how to build a REST API using AWS Lambda proxy integration. With proxy integration, the incoming request at the API gateway is passed on as is to the AWS Lambda. It's the Lambda's responsibility to understand and parse the HTTP request and give an appropriate response. We will learn how to set up and integrate with AWS Lambda from API Gateway, persist the data to a AWS DynamoDB database, and perform create, read, and update operations on these API endpoints. We will also learn how to manage multiple stages in API Gateway and connect to different Lambda and backend services based on the stages that you're running on. Hello everyone, welcome back to this YouTube channel. My name is Rahul and I make videos on .NET, Azure, AWS, and DevOps. Without much delay, let's get started building our API using AWS Lambda. I have my AWS console open here, so let's head over to API Gateway from my recently visited. You can also use the top search bar to navigate to API Gateway. From here, let's first create a new API type. In this case, we will be using the REST API. If you want to build a low latency and cost-effective REST API, you can check out the HTTP API offering in API Gateway. I have a different video which will be linked here which walks through the entire step on building that. But let's get to REST API, which provides more advanced capabilities. Let's click Build to start creating a new API. This creates a sample template, so let's click OK. But let's start with a new API in this option and give this API a name. Let's name this as users-API and give it a description saying this is a user API. It has different endpoint options. Let's leave it as regional. A lot of these options I cover in detail in my introduction video. So if you're new to all this, I highly recommend checking that out first before continuing on with this video. Now in here, we will first need to create a resource for this API endpoint. Under the root path, let's click Actions and say Create Resource. In this, let's give this a name and name this as Users. It automatically gives this a path as Users. So let's click Create Resource. Under the Users resource, let's create a new method. Let's choose a get endpoint. These are all HTTP verbs. So now this will be a get verb which will hit the get endpoint of this API. This creates a new get endpoint setup. And in this case, we will choose Lambda function. This also supports different kinds of integration types. But for now, we will choose Lambda function. Let's click using Lambda proxy integration, which means the request will be proxied to the Lambda and the Lambda will have the entire HTTP request. The other option is the non-proxy mode. We will cover this in a separate video. Let's select the Lambda region and we need a Lambda function to be integrated here. Now since we don't have the Lambda function yet, let's head over to Visual Studio and create our first Lambda function and come back here and continue the setup. So let's open Visual Studio and let's create a new project. I have the AWS Toolkit installed, because of which I have all the templates for building a serverless application using C#. AWS Lambda is a serverless compute service which allows us to run code without having to manage or deploy servers. Now this is the AWS offering for building serverless applications. If you're completely new to AWS Lambda, I highly recommend checking out my video on getting started with AWS Lambda. I also have a Udemy course which covers the end-to-end of building a Lambda function using different AWS services. All the links will be in the description below. But let's continue and select an AWS Lambda project and click Next. Let's give this project a name. So let's call this as users service-lambda. Let's put this in the appropriate folder and let's click Create. This provides an option to select a blueprint. I'll choose empty function and click Finish. This creates an empty Lambda function project using the template. Here we have the functions.cs, which is the Lambda function code. Let's update this function so that it can handle requests coming from the API gateway. For this, we will need to add a NuGet package. So let's say manage NuGet packages and let's search for Lambda API gateway. So this will give us the amazon.lambda.api gateway events. This package has the types which represents the request that's coming from API gateway. So let's install this. Once installed, instead of the string input, we can now take in the API gateway request. So this is going to be the API gateway proxy request. Let's add in the appropriate usings from the NuGet package that we have just added. Now this gives in the input in an API gateway proxy request. Let's also make sure to update the response to be an API gateway proxy response. So let's choose API gateway proxy response class. This stands for the API request and the response that's going to come from the API gateway. So let's make sure to leave this in the new line. If you navigate to the request class, you can see the different properties that's there in this class. It has all the properties that stands for an HTTP request. You can see the resource, the path, the HTTP method, and also query string parameters and other variables. So let's come back to our function.cs. Now let's assume this function is going to handle the GET request, which is going to have a user ID as the query parameter. So let's update this input to be request, and let's first get the user ID from the query string. So let's remove this line and declare a new variable. So let's say where user ID string is equal to, and let's get the request dot query string parameters, and let's get a user ID from that. Let's handle for nulls in the query string parameters. So let's put a question mark right here. Now let's assume our user ID string is going to be a GUID. So in this case, we can say if GUID.tryParse and pass in the user ID string and capture that as a user ID. Now, if this is a valid GUID, we can connect to a DynamoDB database and retrieve this user ID. Now, for that, we will first need to create a new user class. I have a class already written, so let me paste that in here. Now, this simply has a name, ID, address, and an email. Now, you can see the ID is a GUID property. Let's use this user class to connect and retrieve from DynamoDB. DynamoDB is a cloud-hosted NoSQL database provided by AWS services. It is a go-to option when building serverless applications to persist data. Now, if you're new to DynamoDB and not sure how this works internally, I highly recommend checking out my video, which will be linked here. It gives you a good introduction on getting started with DynamoDB. To connect with DynamoDB, we again have NuGet packages, so let's use them to connect it. Now, instead of explicitly adding them, we can resolve them using types from Visual Studio. So let's say where DynamoDB context is equal to new DynamoDB context. Now, since I know the exact type, I can do control dot and it automatically suggests me to install that package, which is AWS SDK.DynamoDB v2. So let's say find and install this latest version. Once that is installed, we can add in the relevant usings for this particular class. Now we have all set up to connect to DynamoDB context. This expects an instance of a DynamoDB client. So let's create an Amazon DynamoDB client class, which again comes from a different using statement. So let's add that. And we have the DynamoDB context all set and connected. We can use this DynamoDB context to retrieve the user class. So let's use the load async method, pass in the user type, and then pass the user ID as well. So we have a user ID, which can be used to retrieve the user from the DynamoDB context. So let's make this as var user and make sure to await this particular call. Now, since we have added an await, let's add in a async method. This also updates the method name with async but let's remove that for now. So now we have successfully connected to DynamoDB context and retrieved a user. Now, if the user is not null, we can return back a successful response. So let's say user not equal to null, return new API gateway proxy response. So we'll need to create a new instance of that. Let's put the status code. In this case, since this is successful, let's make this 200. In the body, we can also add in the user data. Let's use JSON serializer to convert this into JSON object. So let's use text.json and let's say serialize, and let's pass in the user object that we have returned from the DynamoDB class. Now this returns a user object in case it's able to find one. In any other case, we will need to return a bad request because we couldn't find the valid user from this user ID. Or maybe the user ID itself did not exist in the query string parameters. So at the end, we can say return new API gateway response, and let's return this as bad request 400, and let's put the body as bad request. Now you could go ahead and use different request codes based on your API endpoint needs. Now this sets up a minimal Lambda function to handle an API request. The DynamoDB context uses the class name to find the appropriate table. Now in this case, it's going to find the class name as user to find the appropriate table. Now this is purely a convention. You can also use configurations to pass in an explicit name if you want. But for now, I have a user DynamoDB table already created. So let's use that as an example. So if I navigate back to AWS console, let's open this in a new tab and let's navigate to DynamoDB. Under the tables option, you can see the different tables inside my DynamoDB. I have the user table and I also have a couple of other user tables which I'll be using later in this video. Now if we navigate to this user table, we can see the explore table items and we can see a few items inside this. Now if we were to copy this ID, we can use this to query from our API. Now if you want to test the Lambda function that we were building right now, we can do this locally as well. Now you can see this is wired up to a mock Lambda test tool. So let's run this and see how to call this Lambda function. This opens a mock Lambda test tool. So let's select a request type. In this case, I will be using the API Gateway AWS proxy, which has the different options inside here. Now this represents the API Gateway proxy request. So let's update the query string parameters here and pass in the user ID. Let's pass the GUID that we just copied and let's click execute function. This hits the breakpoint as expected. So let's step over this. Now we get the user ID string as expected. Let's do the try pass, which converts it into a valid GUID, and it creates a new DynamoDB context. Now note here, I haven't passed any credentials explicitly to connect to. However, this uses the local configuration to connect to my same AWS account. Now I had done this when I had set up my AWS toolkit. Now under the AWS Explorer, you can see there is a profile default. If you edit this, you can see this has an access key ID and a secret ID that's connecting to Asia Pacific Sydney of my account. Now the DynamoDB context uses these credentials to connect to the appropriate DynamoDB. I walked through this in detail in my credential management video, which will be linked here and in the description below. So let's click OK and let's continue the execution. Now this connects to DynamoDB context and it loads the user. So if you hover over the user, you can see all the details that is for that particular user. And this returns back a status code 200 with the appropriate body deserialized. So if we navigate back to this, we can see the response inside here. Now that we know this Lambda function is working, let's publish this to AWS infrastructure. So let's right click on here and say publish to AWS Lambda. Now this is all coming from the toolkit, so I highly recommend checking out my course or the other video on Lambda to understand more about this. Now let's give this a name. So let's name this as user-service and let's click next. Let's give a role. So let's give the minimal role for AWS. Lambda function. So let's say AWS Lambda basic execution role and let's click upload. Now this is going to upload it into my AWS account because that is how this is connected and that's the profile that it's using from the AWS Explorer that I just showed. The Lambda function is successfully deployed, so let's navigate back into AWS console. Let's close this. Let's open a new tab and let's go to Lambda functions. In here, you can see a new Lambda function that has been just deployed, which is the user service. This Lambda function does not have access to talk to this DynamoDB table. So let's make sure to add that permissions. Under the configuration, let's go to permissions and let's update this role that we just created. Now by default, it only has access to write to CloudWatch. So let's update this to also talk to this DynamoDB table. So under the IAM role, let's add permissions and create an inline policy. We can choose a service and let's search for DynamoDB and select that. In this actions, we need to read the data. So let's expand read and let's say get item. Let's also give the option to describe the table, and let's also make sure this Lambda can put, update, and also delete the item if required. Now we will use this in the later sections of the video. So let's be explicit about what permissions that we give for this Lambda function on this DynamoDB table. Once the actions are defined, let's define the resources on which these permissions apply. So let's specify the ARN to the table that we are interested in. So let's navigate back to the table. Let's go to the view table details and copy the ARN of this particular table ending with /user. So let's come back and let's paste this in here. Now this explicitly gives the access only to this resource of the DynamoDB table. So let's click add and let's click review policy. And let's give this a name. So let's say user service Dynamo policy. And let's click create policy. This adds a new policy under that IAM role. So if we come back to the Lambda function and refresh this, we can now see that this also has access to the Amazon DynamoDB and the user table. Now once this is all set up, let's come back to our API gateway. Now since we newly created this Lambda function, it hasn't detected this yet. So we can refresh this so that it automatically detects the new Lambda function. So let's select here and let's type in user service and select user service from the list. Let's make sure the Lambda proxy integration is turned on and let's click save. Now this prompts us that this API gateway is also going to get permission to invoke our Lambda function. This is required because anytime a request comes at our API gateway, this is going to pass that on to our Lambda function. So when we use the UI to create this, it automatically creates this invoke permission on the Lambda function. So let's click OK, and this adds the permission to our Lambda function. Now if you come into permissions and refresh this again, you can see a new permission that's added under the policy statements, and you can see that this is the API gateway Amazon.com. So if we expand this, you can see the information about this. So you can see this is for the get users and the API endpoint, and it provides the invoke function action. So let's come back. Now in the method request, we need to make sure that we have a query string parameter. So let's add query string parameter and let's say user ID and add this to the list. We need to make sure this is required. So let's check that. Now if we come back to here, we can see the integration request is wired up to Lambda function and it provides the Lambda proxy integration. The integration response is grayed out in this case because this is a proxy integration. The response is expected to be the HTTP method response, which is exactly what we were doing with our response type in our function class. We were returning an API gateway proxy response. Because of this proxy integration mode, we do not get to map the response from the integration. When we do the non-proxy integration, we will be able to do this, which we will see in a different video. So once the method response is here, it will come back to the client. Now to test this, let's click the test. Let's pass in the user ID. So let's say user ID equals, and let's pass in the GUID that we have in our clipboard. And let's click test. Now this sends a request all the way to the API gateway, which hits the Lambda function and it sends back a response. Now you can see here, this is a response 200 and it also responds back with the data that is inside our DynamoDB. Now it says a specific name. Now if I was to come back into the DynamoDB, if we go to the table items and update this object. So let's say instead of prod, let's remove this and let's save changes. Let's come back to gateway and make a request again, and you can see that name is updated. So this is now connected with the get endpoint to a Lambda function and then retrieving data from DynamoDB. With the get endpoint working, let's see how to add a new post endpoint. So we can add an action and say create method, and let's choose post in this case. Now we can either connect this to a completely different Lambda function which we can deploy from our code, or we can connect this to the same Lambda function. So let's reuse our Lambda function and see how we can handle both the get and the post inside the same function. So let's click Lambda function. Let's say use Lambda proxy integration, and let's choose the same user service, and let's click save. Now this is again going to give a permission which is for the post endpoint and for this Lambda function. So let's say OK, and this is going to add the permissions inside this list here. So if we refresh, we will be able to see a different record which will be for the post endpoint. Let's come back to our Lambda function and see how we can update this to handle both the get and the post request. Right now, this piece of code is handling the get request. So let's refactor this out. So let's use Control RM and create a new method. In this case, let's name this as handle get, and let's apply the rename. Now this is going to handle the get. Now we also need to handle the post. But first, let's make sure we return based on the HTTP method. So in this case, let's handle the request.http method, and let's use switch case on this HTTP method. Now in this case, if this is a get, then we need to use the handle get, and if it is a post, let's use the handle post method, which we are going to just create. So let's say handle post, and let's pass in the request again. If it is anything else, let's return an internal server error. So let's create a new API gateway proxy response and set the status code as 500. If you want, we can also set up the body as unknown request. Now let's make sure we create a new method, handle post. Let's make sure to close this function appropriately, and also let's remove the extra braces at the end. Now this is compiling all successfully, which means we have handled both the get and the post request. Now let's go ahead and implement our handle post method. In here, let's assume that we are going to pass the user object in the request body as a JSON object. So from the request.body, we can deserialize it as a user object. So let's say var user is equal to JSON serializer.deserialize user and specify the request.body. Now if the user is not null, so let's say if user not equal to null, we can use the DynamoDB context and write this inside the database. Now we already create the DynamoDB context here. So let's grab this and let's make sure to create this as a function constructor. So let's create a new constructor and let's save this as a DynamoDB context as a class variable. So let's create a field and we can start using this instead of instantiating it inside every method. So let's remove this and let's update this to use the underscore DynamoDB context. Let's also make sure this is not static so that it can use the class variable. Now anytime a new Lambda function is instantiated, it is going to create a new instance of this DynamoDB context and use that throughout that function's lifetime. So let's use the same DynamoDB context and call the save async and pass in the user object. Now this is going to save the user inside that DynamoDB table. So let's await this call, and once that is successful, let's return a new API gateway proxy response and let's set the status code as 200 and let's add the body as user added. Now since this is an await call, let's make sure to add async to this. Now if this user does not exist, let's again return bad request. So let's copy and paste this and return a bad request. Now you can refactor some of these API proxy responses into a separate helper functions. But for now, let's leave it like this. Now this is going to handle both the get and the post request. So let's make sure this builds fine and let's publish this to our Lambda function. So let's right click and say publish to AWS Lambda. Now I have all the details pre-populated, so let's simply click upload. This is going to replace the previously deployed Lambda function inside my account. Now once that is set up, let's navigate back. Let's go to the API gateway. Under the post, let's click test and let's pass in a user object. I have the body already copied, so let's paste that, which has the ID, the name, address and email. So let's click test and this sends a new request and it responds back with a 200 user added. Now let's navigate back to our items and let's refresh this and we can see the new object that's successfully added. So if we click this, we can see this ID with the name Rahul and the email address and address. Now if I come back to API gateway and if I modify this, so let's say this is Rahul Nath and let's click test, this again sends this request with the same ID. Now you can see this is also responded back as 200 and user added. Now if we come back to DynamoDB and let's refresh this, and you can see the name is already updated. Now in DynamoDB, the same saveAsync method updates the object if it already exists. So we have handled create and update with this single post method. Now if you want to also do a delete method, you know how to do this. We'll need to add a delete statement and handle the delete, get the ID and delete the item from DynamoDB. I'll leave that as an exercise for you. Until now, we have been building and testing the Lambda function within the API gateway. Let's publish this to a stage so that we can start using this from an external URL. So let's go into Actions and let's click Deploy API. Let's choose a stage. In this case, since we don't have any, let's create a new stage. Let's name this as Production because this is the production instance of the API endpoint. So let's say Production Users Service and let's click Deploy. This creates a new stage called Prod and deploys the API inside that. You can see all the request endpoints in here. Now this is where you can handle all the configurations for this API endpoint. Now to test this from here, let's invoke this URL and let's go to /users. So let's pass in the user ID equals and give this the GUID of the item that we just added. So let me copy that from my clipboard and let's make this request. Now you can see this returns back the data for Rahul that we just added. So this is using the URL to prod and it's passing in the user ID. Similarly, we can also make a post request and add a new item. So let's open Postman to create a post request. So let's copy this URL. Now Postman is a free utility that you can use to make post requests and other HTTP requests. It's freely available and I'll put a link in the description below. So let's click the plus and add a new post request. Let's pass in the object. So let's remove the user ID since that is not required. Let's pass the body. Let's make sure this is raw and in JSON format. Let's pass the JSON request here. So I have it already in my clipboard and let's update this again. So let's say Rahul Nath and let's also say I am in Brisbane, Australia and let's click send. Now this returns back a 200 OK and the message would also be there as user added. Now if I come back to DynamoDB and refresh this, you can see my address is now updated. So I have successfully published this API into a prod instance and connected it using the URL. Now let's say we want to add a test stage as well. Before we roll out our changes to production, we want to be able to test the changes that we are making and see this in a safe environment. So let's come back to resources, let's go to actions and let's say deploy API. In this case, let's create a new stage and let's name this as test. So this is going to be test user service as a stage description and let's click deploy. Now we have two stages, one is test and the other one is deploy. So let's navigate to the test URL and let's pass in the /users and let's pass in the user ID and let's give the same user ID. Now in this case, this is again going to connect to the same backend. But this is not what we want. In the test environment, we want the API gateway to connect to its own version of Lambda and also DynamoDB. we don't want to be updating or modifying the data in our production environment. So let's see how we can connect based on the stages to different backend services. So let's come back to our API gateway and we will use stage variables for this. Under the test stage, let's add a new stage variable called environment env and let's add the value as test dash. Now any of the test resources is going to have a test hyphen following it. Now the prod resources will not have this. This is purely a convention that I have chosen. Now you can choose whatever convention that works for you and the team that you're working with. Now you can have prod dash appended before this or at the end of the services. Now that's totally up to you. But in this case, let's say all the Lambda functions or DynamoDB database for the test stage is going to have a test dash appended to it. So let's come back to our resources. Let's go to the get endpoint and let's update the integration request. Now instead of simply connecting to the Lambda function user service, I'm going to also specify the stage variable, which is using $bracket stage variables dot env. And let's prefix that inside the name. So I'm using stage variables dot env. So let's check this. Now this is automatically saying that you have defined the Lambda function as a stage variable. So please make sure to explicitly add the permissions when you're setting up the Lambda function. Now in our case, for the test, we have already given the appropriate permissions, but we don't have a test user service yet. So let's come back to our Visual Studio and let's deploy the same instance as a test version. Now before we deploy a different instance of this into the test environment, let's also make sure that it is able to connect to a test DynamoDB database. Now in this scenario, the DynamoDB context is you're going to use the class name as a convention to find the table. Now we can update this when we set up the DynamoDB client. So let's say we have a new environment variable. So let's specify environment and let's retrieve this from the environment.getEnvironment variable. In this case, let's assume we have an environment as a variable inside this. And when we create the DynamoDB client, we can also specify a DynamoDB config. Now in this case, we are going to specify a table name prefix for the table names inside the environment. So all the environments is going to have a prefix of the environment that we are going to set as an environment variable. So in our case, when we deploy this Lambda function into the test instance, we are going to put an environment variable which is going to be having test dash as a prefix. This ensures that when we connect to the user table, it looks for a test dash user table because that is what we have set up in the configuration. Now when the environment is going to be empty, which is going to be the case for the production environment, this is not going to append any prefix. So it works as expected. So let's make sure that this builds fine. Let's first deploy this into our prod instance. So let's simply deploy it to the same user service. So let's click upload, which refreshes our current production instance, and it is all successful. Now let's also make sure to deploy the same instance to a test version. So let's say this is going to be a test user service. So let's append it with test dash because that is what our API gateway is going to connect to. So let's click next and let's give this the basic execution role that we first gave for our Lambda, which provides permission for CloudWatch logs. And let's click upload. Now this is going to upload our test version of the same Lambda function. Now if you have a build deploy pipeline set up for your Lambda function, you can first deploy it to your test environment and then progress it to your prod once you have done testing. If you want to learn how to use CloudFormation and set up an automated build deploy pipeline for your Lambda functions, check out my video linked here or in the descriptions below. Now our test Lambda function is successfully deployed. So let's navigate back to the console. Let's go to the Lambda and let's navigate back to functions. So here we can see there is a test user service and also the user service. Now let's make sure to give the test user service the appropriate permissions to connect to the DynamoDB table. Now if we come back to the DynamoDB, you can see here as well under the tables, I have a test-user table. So let's come back here, update the IAM policies for our Lambda function, Let's add an inline policy. Like before, let's choose a service which is DynamoDB. Let's make sure to give the actions. So let's say read, describe table, get item, and under write, let's make sure to give delete item, put item, and update item. Let's make sure to expand this and specify the resources. So if we come back, let's give this for the test-user table. So let's copy the ARN for that and let's paste this inside here. So let's specify the ARN and paste it in here. Now this is giving it access just to the test-user table. And let's click add. And let's click review policy. And let's give test-user service-dynamo policy. And let's click create policy. Now this creates a new policy just for that test execution service. So if we come back to our Lambda function and refresh here, we can see this has access to the DynamoDB as well. Now when we set up the API gateway, you can see this has mentioned that we need to explicitly set up permissions for our Lambda function so that it can be invoked. So let's copy this source ARN and let's give permissions to our Lambda function. So under the policy statements, let's click add permissions. Let's select the AWS service. In this case, we are going to give the API gateway. Let's give the source ARN. So as specified inside here, let's copy this. Let's also copy this random GUID. You can also generate a random GUID if you want, but I'm just using this in this case. Let's come back and let's paste this as the statement ID. Now inside the action, we can say Lambda invoke function because that is what it requires, which is also specified in here. So if you see the action, that is Lambda function. Now this is giving you the script to run this from the AWS console, which is also something you can do. Now let's come back to add permissions. Now instead of explicitly specifying for all get, post, and other HTTP verbs, you can also use a wildcard inside here. So instead of get, we can replace this with star, which means it is available for all the HTTP verbs. Now once that is specified, let's make sure to click save. And this gives the API gateway the appropriate permissions to invoke this new test Lambda service that we have updated. Now with all that set up, let's come back to our API gateway, click OK because we have given the appropriate permissions, and it's also updated to this stage environment variables. Now let's copy this and update our post endpoint also with exactly the same. So if we go into the integration request, let's edit this and let's paste this in here. So this is also going to connect using the same convention. So let's tick this, which is going to prompt you to give the same API permissions. Now since we gave it for all the HTTP verbs, we don't need to do anything for the post method. So let's click OK. And let's deploy this new updated API. So let's deploy the API first into the test stage and click deploy. Before we test this new deployment, let's make sure under the test user service Lambda function, we add the appropriate environment variables. Now when we set up the DynamoDB, we have given it that it has to connect to the environment variable and use that as the table name prefix. So let's come back to the console and let's add a new environment variable. So let's click edit and let's say add environment variable. Let's give the key as the environment name and let's pass this variable as test dash. Now this is going to connect to the test dash user table in this particular environment. Now with that all set up, let's navigate to the DynamoDB table. So if you look at test users, we don't have any items in here. So we can use this URL to first post a new item inside the test database. So let's navigate to this. Let's copy this, come back into Postman. Instead of the prod environment, let's connect to the test environment and the /users endpoint. Now instead of the name Rahul Nath, let's give this Rahul test. And let's send this into that API gateway. Now this is going to return a 200 OK. And also says user added. So let's navigate back to our DynamoDB and let's refresh this. Here we can see the item that we have just added into the test user table. You can also see this was invoked by our test user service. Now if we add a new item inside this, so let's come back here and instead of 1, let's use the ID as 2. and let's say AWS-test, and let's say AWS, and click send. Now this is also going to send. Let's come back and refresh this, and you see the new item in here. So let's copy this ID. Let's come back to the URL here for the get. Let's say /users user ID equals that ID that we just added. Now this sends back the name AWS test and the new item that we have added. Now if we deploy this into the prod stage, so let's come back to resources, let's say actions and say deploy API, and let's select prod. Let's give this updated to stage variables, and let's deploy. Let's navigate to this URL. Now if we were to use the exact same user ID, we wouldn't find that item inside the prod instance. This is because that is living inside the test database. So it returns us a bad request. Now if we come back to items, go to our user database and copy another ID from here and use this inside our execution, we are going to get back the data as expected. So we have successfully connected the API gateway based on the stage it is running on to the appropriate backend resources. In this case, we used the convention of appending the resources with the test dash to identify the resources based on the environment. So inside the Lambda, you can see we have the test dash for the test environment and without any prefix for the prod environment. Similarly, for the DynamoDB as well, the user is for the prod environment and the test dash is for the test environment. Now, if you want an additional environment, you can also name it with the appropriate prefix. In this case, I have a def dash that is defined for development if you need an extra environment. I hope this helps you to understand how to build a real-world API using the REST API product inside the Amazon API Gateway. We learned how to connect to a AWS Lambda and all the way through to a DynamoDB table. Now, there are a lot of services that we covered in this video, especially the API Gateway, Lambda, and also DynamoDB. Make sure to check out my AWS playlist to get more details on each of them. As we saw in this video, we used the Lambda proxy integration method, because of which we handled the bare bones of the HTTP request inside our Lambda function. In a different video, I will show you how to use the non-proxy integration with Lambda functions. If you want to be notified when that comes out, make sure to hit the subscribe button. If you have any questions or feedback, make sure to leave them in the comments below. Thank you and see you soon.